So hello. So a lot of things like car suspensions, balances and so on rely on springs, right? To some extent our muscles do too. They stretch and they compress. When that happens, to stretch something, you have to apply force. And conversely, if something's being stretched, a spring's being stretched, it applies a force on whatever is stretching it. Now that force, of course, as you put harder on a spring harder and harder, you need to apply a greater and greater force for it to get longer and longer. We're going to describe this using Hooke's law. So in Hooke's law, let's think about, say, if we are stretching. So a spring, something like a spring, will normally have some natural length. So if I don't have anything going on, it has some natural length, okay? Now, what if I pull on it? Okay. Then it's going to be extended, right? We're extending it by some distance x over here. And therefore, it's going to pull on whatever is attached here. So let me draw this box. It's going to pull on this by some force, opposite to the direction that it is being stretched. So the force exerted by the spring on the end, this force is then minus kx. Okay, so this is the force. Minus here is because, of course, it's pulling in the opposite direction to which the extension is occurring. X here is the extension. So we have to be careful. It's not the total length of the spring, but it's the difference between the length of the unextended spring and the extended spring. And over here, K is the force constant in newtons per meter. Okay? The other way to look at this, of course, if you think about it, we can think of also having a spring, the same spring now, but to keep it out here, we have to apply a force, right? Now this force, if you compare this force and this force, remember Newton's third law, the force used to extend the spring exerts on whatever object has to be equal and opposite to whatever force that object exerts on the spring. And therefore, the force that the external object exerts is equal to kx. Okay? But the basic idea is that the magnitude of this force is the force constant times x.